Let's go ahead and put together a little hierarchy so that we can wrap our head around the inheritance feature. So I went ahead and created a new project, What's New, and I'm going to go ahead and clean this up a little bit because we don't need all of this junk, as you know. Okay, so what I'm going to do here at the top, I'm going to create another class and say class. And this is going to be person. That's the name of the class. And person has string name, last name, such. And you notice this may be a little bit different syntax, as you can see. Now, because we have the same type, okay, all these are string, we can actually create instance variables or member variables in one line because they're the same type. But now if I want to say int different type, I'm going to say int age. Okay, I can't put it here because this is a different type. So let's see, what else does a person have? Let's see. And we can say here nationality. And those are, I think those are enough. Perfect. So we have a very simple person class with name, last name, nationality, and age as instance variables. I'm going to say class. And this is going to be a concrete. I'm going to call this Bonnie. In order for us to inherit from person, we use the extends keyword, which means inherits. Okay, I don't know why use extend instead of just say inherit. Oh well, we just stuck with this. Okay, Bonnie extends what? Person, just like that. Okay, now I'm going to go ahead and create a method here. I'm going to say void, a function, void show name. Make sure this is a method as such, and I'm just going to go ahead and print that name, okay, whatever we have set. Very simple. Notice something very interesting here. So what we did here again, we said Bonnie extends, which means inherits from person. This means that Bonnie inherits everything that the person has. You want to see if that's true? Check this out. Let's go to main here. What are we going to do? We are going to go ahead and instantiate a Bonnie. Say var Bonnie is equal to new Bonnie as such. If I say Bonnie dot, look at this. Now we have fields name, age, nationality, and last name, and we even have the show name. Look at that. Okay, if you notice, Bonnie class doesn't have any of that we explicitly have written. Yet we're able to get show name and anything else we want. Of course, it's not going to show anything because we have to set Bonnie dot name to be Bonnie as such. Okay, so now if you save it and run, you should see Bonnie. Now this proves to you that indeed Bonnie extends from person, because how else would Bonnie know of name and show name and other things that are just for the person? Okay. Now the beauty here, because remember, when we inherit, we are inheriting all of the parents' features, attributes, and methods, and so forth, right? But remember, we are also, in this case, Bonnie. Bonnie is her own person per se. So Bonnie could also have different assets or different attributes, right? If she wanted to. She get a string profession like that. Right? Now I can go ahead at bottom here and say Bonnie.profession ballerina as such. Right? I can say print. In fact, I can even go here and create another method. Say void show profession. I can just use the easy one here. Say print profession as such. Okay, I can just go ahead and say Bonnie.show profession. There we go. Run says ballerina. So in this very simple example, I was able to show you this hierarchy in which we were able to create the person as the parent class, and we created Bonnie, which extends person, which means inherits from person. which means it gets all of this property, everything that is inside of the person class. And I could create here another one. I can say class Paulo extends person. The same thing will happen. So now we're creating all of these classes, right, which will have a template of the person class, because we know Bonnie is a person, Paul is a person, Anthony is a person. Since they're a person, why not inherit from person? That way we won't have to go ahead and create Paulo with all of these attributes and methods and so forth. Create Bonnie and all of these attributes and methods and so forth. That would defeat the purpose, right? Because we're trying to compartmentalize our code and make it efficient, as opposed to keep creating different classes that otherwise we could have just inherit or use the default properties that we can set as our parent class here. Again, if I come down here, I can go ahead and say Paulo, let's say var Paulo is equal to new Paulo, okay? And I can say Paulo dot name is equal to Paulo. I can even say Paulo dot age. I'm 32. So young and old at the same time, right? And if I wanted to, I can also go ahead and say here, add something else. Let's say I want to say string. In fact, I can say string, or I can even say bool, play guitar, as such, as a boolean. I can even set here Paulo dot play guitar is true. There we go. I can say Paulo dot show name, as such. If you run, it should show Paulo's name. There's Paulo. I can go ahead and say Paulo dot age. It should say 32. Actually, I have to print it, obviously. Right? You can say 32 and so forth. You get the idea, right? All of that, again, we are inheriting from person. And we can keep adding other methods or anything else we want, but knowing that as we add all these things, we still have access to our parents' properties and methods. That is the power. So now we can make Paulo special, different Paulo, but the basic of who Paulo is, it's still a person. Perfect. So as an exercise, I want you to do the same thing we did here with any other object in the real world. That could be a car, a house, a tree, an animal, whatever you can think of that you can actually put together a hierarchy of the parent class and then other classes that we inherit from the parent class. And you can add all of the attributes and member variables as well as methods and start playing around with this concept just like what we did here. Right? All right, folks. Perfect. I will see you next time.